Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 55 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from permutations and combinations and probability. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more such videos, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. So once you sign up, you will get access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD, and VRs. We'll be uploading 100 tests in each section, which you can attempt absolutely for free. So if you're a serious CAT 25 aspirant, you cannot afford missing those, right? So without any further delay, let's get started with the first question. Find the total number of terms in the expansion of A plus B plus C plus D plus E over 40. Now, if we have A plus B plus C plus so on till K terms raised to the power N, if you are asked to find the number of terms in the expansion of this polynomial, then that would be N plus K minus 1 C K minus 1. You can simply remember this formula. Here the value of K, since we have 5 terms, the value of K is 5 and is 40. So 45 minus 1, 44. C, 5 minus 1, 4. So 44C, hence option C should be the answer to this question. Now coming to the second question. In how many different ways can 3 distinct rings be worn in 5 fingers of a hand? So we have 1, 2, 3, 4, 5. Right. So one way is all 3 rings in one finger and 0 in the other 4 fingers. Right. Or 2 in one finger, 1 in the other, and no ring in the other 3 fingers. Right. Or each ring in 3 fingers and no rings for the other 2. Right. Now if I consider this, now we need to select one finger out of 5. That can be done in 5C1 ways. Then now you will be putting all the 3 rings, and you can also arrange those 3 rings in how many ways? 3 factorial ways. Right. So 5C1 is 5 into 3 factorial, 6. 5 into 6, 30. So you have 30 ways. Now coming to the second case, where you have 2 rings in one finger and 1 ring in the one of the other fingers and no ring in 3 fingers. Right. So first let's select one finger, so that we'll be putting 2 rings in that. Right. So that can be done in 5C1 ways. Now we have selected that finger. Now we should be putting 2 rings from 3 different rings. We have to select 2. That can be done in 3C2 ways. Okay, so we have 2 rings with us. Now they can be arranged in how many ways? 2 factorial ways. 2 factorial into. Now we are left with one more ring that can be put in the other 4 fingers. So 4C1. Now this would be 5C1 is 5, 3C2 is 3, 2 factorial is 2. So 5 into 6, 30, 30 into 4, 120. Right. Now the third scenario, 1 ring to each finger. So from 5 fingers, we need to select 3. That can be done in 5C3 ways, and we need to arrange those 3 rings. 3 factorial. Right. Now 5C3 is nothing but 10. 3 factorial is 6. 6 into 10, 60. So 30 plus 120, 150, 150 plus 60, 210 should be the answer to this question. Now coming to the third question. In how many ways can 4 boys and 4 girls be made to sit around a circular table if no 2 boys sit adjacent to each other? So we have a condition with respect to boys here. So first let's place girls. Right. Now in how many ways can we arrange 4 girls to sit around a circular table? 3 factorial ways. So 1, 2, 3, 4. Now after placing 4 girls, we have 1, 2, 3, 4. 4 places to accommodate boys. So they can be arranged in 4 factorial ways. So the value of 3 factorial is 6, 4 factorial is 24, 6 into 24, 144 should be the answer to this question. Now coming to the fourth question, in how many ways can K purchase 7 identical garlands from 4 shops such that she purchases at least 1 garland from each shop? Now let the 4 shops be A, B, C and D. Now she has to purchase a total of 7 identical garlands, and it is also given that she has to purchase at least 1 garland from each shop, right? So she should be purchasing one from A, one from B, one from C and one from D. Right. So she had purchased 4 garlands. She is left with 3. Right. She has to purchase 3 more. Right. So that can be done in 3 from one shop and no garland from the remaining 3 shops, or 2 from one from the other, 0, 0, or 1, 1, 1, 0. Now I want you to understand that these are identical. Right. So out of 4 shops, now she has to select one shop where she can purchase the remaining 3 garlands. That can be done in 4C1 ways. Now coming to this, she has to select 2 4C2. Now from one of the shops she can purchase 2 garlands and from the other 1, and vice versa. So for every selection there will be 2 possibilities. So 4C2 into 2, right? Now here she has to select 3 shops, and from each shop she will be purchasing only 1 garland. So 4C3. So 4C1, this is 4, 4C2, 4 into 3 by 2, 6, 6 into 2, 12, and 4C3, again 4. So 12, 12 plus 8. This can be done in a total of 20 ways. Now coming to the last question. 2 persons A and B throw a die alternatively till one of them gets a 3 and wins the game. Now find the respective probabilities of. Now when can we have person winning the game? When he throws 3. Right. Now what is the probability of getting 3 in his throw? 1 by 6. Now what is the probability of not getting 3? 5 by 6. Right. Now when can we have A winning? A could have won in his first throw, or A lost in the first throw, B also lost in the first throw. Then we can have A winning in his second throw, right? So that would be LLW plus A lost in his first throw, B lost in first throw, A lost in second throw, B lost in second throw, A won in his third throw, and this continues like this, right? Now what is the probability of A winning? 1 by 6 plus A losing 5 by 6, B losing 5 by 6, and A winning 1 by 6, plus in this case A losing 5 by 6, B also losing 5 by 6, A losing again 5 by 6, B also losing 5 by 6, and A winning 1 by 6, and this continues till infinite turns. Right. Now what can I take common? I can take 1 by 6. Then what do we have? 1 plus 25 by 36 plus 25 by 36 whole square and 25 by 36 whole cube, and so on. Now this is nothing but sum of infinite GP, right? So this will be equal to 1 by 6 into A, 1 by 1 minus R, 1 minus 25 by 36. So on simplification, we have this is equal to 1 by 6 into, I can take 36 to the numerator, 36 by 36 minus 25, 11. Now 6 are 36. So probability of A winning the game is 6 by 11. Right. So the probability of A winning the game is 6 by 11. What is the probability of B winning the game? 1 minus 6 by 11. That should be 5 by 11. Hence option A should be the answer to this question. They won't be having equal chances of winning because A is the one who is to make the first throw. He will be having a higher probability of winning the game.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.